Merhaba herkese. Teşekkür ederiz yayınımıza katıldığınız için. Bugün ben ve beraber çalıştığım bir arkadaşım Pierangelo ile bir sunum yapacağız. Sunumumuz AI Ready Microservice Architecture isminde. Ve bir dakika sonra ya da birkaç saniye sonra diyeyim, bir yarım dakika sonra başlayalım. Sunumumuz İngilizce olacak. Pierangelo yabancı olduğu için diyeyim. Ve biraz Türkçe başlangıç yaptıktan sonra şimdiki gibi sonrasında İngilizceye döneceğiz. Son olarak şunu da ekleyeyim. Bu bir CNCF İstanbul grubu etkinliği. Yani CNCF'in Code of Conduct'ı burada geçerli. Bu da şu demek, yazdığınız yorumlarda veya genel itibariyle birbirimize saygılı ve nazik olmaya çalışalım. Ve şimdi Pierangelo'yu ekrana ekliyorum. Sonrasında İngilizceye artık dönüyoruz. Sorularınızı yorumlara Türkçe veya İngilizce yazabilirsiniz veya istiyorsanız İtalyanca da yazabilirsiniz. Teşekkür ederiz. Hi, Pierangelo.
Hello.
Hey. So we're live, and before starting the talk, can you introduce yourself?
Sure. Hi, I'm Pierangelo. I'm a software engineer at Red Hat, and I'm the Knative eventing tech lead. That's it.
Yeah, thank you. So Pierangelo and I are working in the same team. I also work for Red Hat. I'm also one of the organizers for this Cloud Native community group, Istanbul. And we wanted to do this presentation here for our community. So let's start. Pierangelo, I'm going to remove you from stage. Okay, so AI-ready microservice architecture. And, AI is a big thing, and it cannot take over with monoliths. You need microservice architecture. So we introduced ourselves. We work in the same team at Red Hat. We are both Knative contributors. Pierangelo is the lead for Knative eventing in the Knative project for eventing module, and I'm an approver and a contributor to eventing and a bunch of other modules. Okay, why AI and why now? AI is getting a lot of investment, really a lot. I mean, this is no surprise. This is not news for anybody. And it is happening in front of our eyes. And everybody wants to have their share from it. However, investing in AI was not very easy in the past. Now it's much easier. Some of the problems are solved, or some of the situations are improved. Like you have more data, you have scalable infrastructure, and there is also this uncertainty which is eliminated. What I mean by uncertainty is if something is gonna work out in terms of commercial success. And we want to introduce you a tangible example for this presentation. And this tangible example is brand detection, or more specifically, detecting images for a brand. So let's consider a brand detection use case that studies how the public perceives and interacts with a specific brand. That means if you post something about a brand, like the logo or some product of a brand with some text, you need to first get the image. Like, you need to understand if the image contains your brand, and then there comes the other things like text, like what's the word? If there's a good emotion in it or a bad emotion in it, something like that. But for this demo, for this presentation, we are mostly focused on the object recognition part. So for this, we thought we could have something like a very simple design. We could have very simple application. So we could have a logo detector. So this logo detector would receive images from browser or in general clients, and it would produce some detections, like there is this possibility of having your brand logo or image, whatever, in the image uploaded. But our thinking is, would it work? So here then we need to talk about a little bit, if to understand if this would work, we need to think about a little bit if like what are the common reasons for AI project failures. Some of them are technological issues, and some of them are not really about technology, like unrealistic expectations, meaning things like misunderstanding of AI capabilities, thinking too big or too small, or use case related issues like not finding the good balance of cost versus benefit, etc. And there are a bunch of other things like organizational constraints and lack of key resources and people, but we are here to talk about the technology part. So one big problem with AI systems are that they are opaque, so you cannot really understand what is going on, and how a deep learning system, for example, makes their decisions. So what can we do about this? We can do some monitoring. And what I mean by monitoring is, for example, we can store the predictions that the logo detector does, and then store them somewhere so that we can actually make some analysis later. So the logo detector in this architecture, in this case, would need to talk to a object store and a database, because it needs to store the image that the user or the client sends, and it also needs to store its own prediction. And then later on, you can combine this information and make some analysis. Okay, but there's an issue here, which is atomicity. So if we were using only single database, we could have actually some database transactions, and we could just save everything at once. But here we have two different things. We have the object store and the database, because you cannot really store an image in a database. It doesn't make sense. So if something fails here, like the logo detector fails, you could have an image which has no prediction. Or if the database fails, you have again the same issue. Or if the object store fails, you have an image, but then you don't have any prediction for that image. So this is all good. So this is one of the pain points. Let me go back. This is one of the pain points. The other one is, so the other kind of monitoring option is not really monitoring, but getting user feedback. So this is something that one can use to understand what's going on in their AI systems. So in this case, logo detector or this system would actually receive a feedback from the user, and then it would store the feedback in a database. It looks very simple. But when you think about this, now the logo detector has two responsibilities, or bunch of responsibilities, but it will receive two requests from the user. One is the upload, the image upload. The other one is receiving the feedback. and it will talk to again these two systems. There is still problem with atomicity. Now we added also the feedback storage, and here we have a bunch of issues. One is that you need to make some changes in the logo detector to so that it actually talks to the database and stores the feedback there. And the other issue is that you have a shared data store. So why would you have your prediction and the feedback in the same database? This is important because later when you're doing the analysis, you wouldn't want to use the same database because it will affect the performance of the whole system, because um, this will be the bottleneck here. So basically, in this architecture, we have some scaling issues, and these scaling issues are related to compute and people. So to kind of reiterate, it has the logo detector system has too many responsibilities. It's not modular. It actually scales database for two separate use cases, and for a new use case, we have to change the existing service. Let's say you want to have also the text sentiment analysis for the social media post you found. You don't want to change the code for a logo detector, right? So these are all the issues that we have. However, there is an alternative, and that alternative I'm gonna switch to Pierangelo. He's gonna talk about the better alternative.
All right. Um, so before we start with the alternative, all right.
Can you share can you share
Yes,
your
let me
screen?
share my screen. I should see my screen. All right. Before we start with the alternative, I'd like to kind of recap what are the use cases for the use cases that we gone through and we designed with these initial architecture. And the three main use cases is be able to detect the logo into uploaded images by a client. The other use case was receiving feedback in a way that we could analyze the model and how it's actually behaving with the actual users, and also be able to kind of look at the feedback and as well as the predictions and be able to make sense of them and also analyze them in a way that we could improve the user experience. And with these, the initial version, we kind of have bundled everything into one main service pretty much. And so with this alternative, we'd like to kind of split the architecture into multiple services that are independent from each other, and they kind of work together. And we kind of split the various use cases in different one or more services, and with one single responsibility each one of them. For the first use case, there is the upload scenario, which is the client is uploading an image, and we have an upload service, which is just simply storing the image into the object store. And then the object store is going to emit an event when a new image is uploaded to it. And we are going to deliver that event to an event broker, which is our event bus, and the component that makes sure that the other services are aware that this event is happened in the system. And so for the actual logo detection, we basically attach to the event broker. We bind basically the event broker to the logo detector to the event broker, and so that it listens for image uploaded events and can then reply back with a new event which is containing the actual prediction, which is basically the detection of the logo. And so the logo detector is basically the service that is like and has one only responsibility, which is receiving image uploaded events and reply back with the actual prediction of the service. With this new architecture, we kind of need a mechanism to kind of reply back to the user with the actual prediction. And with the async architecture nature of this new design, we need a component that is kind of bridging between the client that has uploaded an image and the prediction broker, which is containing all the predictions done by the logo detector. And so we introduce a new reply service, which is connected to the client with WebSockets and is basically pushing back the prediction to the user, so that we can show that a given logo is detected into a given image that was uploaded. And so with that, we kind of have solved the first use case, which is detecting logos in uploaded images. To solve the second use case, which is exactly receiving feedback from the user, we introduce a new service, which is receiving the feedback event and is storing that feedback into another event broker or event bus. And this responsibility is really simple. We can implement that as a simple like fast function or a simple service. And with that, we kind of receive feedback use case. We can kind of store this feedback somehow. And the last use case of this like architecture and this application, we need to kind of be able to make sense of the predictions that the model has done and the feedback that we got from the user, so that they both ideally we maximize user feedback and we improve our model. And with that, we kind of we need to simply introduce a new service, and this service is going to be responsible for storing predictions as well as feedback that we have received, one from the logo detector through the event broker predictions, and one from the feedback service through the event broker feedback. And by storing these, with this new architecture, we are able to kind of solve a new use case by simply adding a new service as opposed to modify the existing ones. And we're going to see why this is important, especially for AI later on. So with this, we have solved all use cases with the main ones, and so we come up with these architectures there are quite a few components. We're going to talk about maybe later on about the benefits of these as opposed to the previous one later on. But now I'd like to kind of pass it over to you, Ali, again for the demo. Here is the QR code. If you need to you can scan it, and you can use the app live as well as we are doing it.
Yeah, thanks, Pierangelo. So if you would like to participate in the demo, please scan the QR code. It will have a URL. It has a URL in it, and if you go to that URL from your mobile phone, preferably, you will be seeing basically this. Let me show you what you'll see. 1 second. You're gonna see this application. So let me give you a little bit of more time if you want to scan the QR code for 10 more seconds. Okay. Now you should see this application. It's a very simple application. If somehow if the URL has HTTPS, please change it to HTTP because this is a demo and some stuff is not ideal. So basically the encryption. But other than that, it should just work. So if you click somewhere on the screen or click this red circle, since I'm on PC, I just have an option to select an image, but on your mobile phone, you will have the ability to take a photo. And that photo, if there is a Knative logo in it, the application should recognize it. And in case you need it, here is a Knative logo. I will keep it open if you want to take photos from your TV or your phone or yeah, like laptop or whatever. Okay, so let me try some images. So this is a very simple image that I took early on. It has this Knative logo here, and the background is a map of Africa. And once we submit this to the application, it says, great, here's the Knative logo. And there's a feedback option, so I give a thumbs up now. And then you press this button, you go back, you try again. Now I'm gonna try this image, which is a bit hard, which is a bit like, even as a person, as a human, it's a bit hard to see the Knative logo here, but it is right here. I don't know if you can see my mouse cursor, probably not, but it's on the like bottom left cornerish place. So let's try this one too. I'm gonna send it. It evaluates, and yeah, you can see the green rectangle here that it was able to recognize it. Another thumbs up. Let's try again, and this time it's a bit different image. So this time the Knative logo is a bit small compared to the rest of the image. Let's send this one, and it says not Knative. So it's a very kind of actually silly application that it only recognizes the Knative logo and nothing else. But there's anyway. Let's go back to the actual image. There is a Knative logo here, but the system is not able to detect it. So I give a thumbs down as a user. So obviously there is some improvements that need to be made, but how is the system administrator or the application owner is going to know about it? And now I switch it over to Pierangelo because I'm the end user and he's gonna play the administrator side. Yeah, you're on. Your screen is on stage, Pierangelo.
I guess you can see my screen. Okay.
Yeah, we can.
So the idea is that be able to, as we saw in the architecture, we need to kind of be able to look at the data and see if like we can improve the model. And in our case, like we have built like these Grafana dashboards that have they show basically the model, like some model data that we have kind of collect like we kind of show like the model confidence, like the negative feedback as well, or the like or even like the feedback over time to see like if the user experience is like positive or negative. And so for each individual case, I can kind of click on this, for example, like on this last one. And as you can see, this is the example that Ali was sharing earlier. And like even if the logo, like the model found that there was a logo here, but it was not confident enough to kind of show, yes, there is Knative logo here. And
sorry to interrupt. Can you make the font size a little bit bigger?
yeah.
Yeah. Okay. Thank you.
Okay.
Refresh, so that it looks better. The image as well. Yeah.
Okay. And the idea is that once the model is not confident enough into finding the logo, it says no, I didn't find it, even though it actually found it. And so we got a negative feedback. So we can look at the actual example here, and you can say, okay, the model is not good enough. We need the new model. We need like to improve it. And for this, we kind of train the new model, which is kind of let's say the version 2. And so we are gonna like go through like what it looks like to kind of to kind of update like the our inference service, which is the service that is like responsible for actually serving the actual model, which is like a TensorFlow model in this case. So we're gonna go ahead and update like the image to like v2 in this case, update the service, and once it goes through, it's gonna like deploy the service, and we're gonna see it live soon. Okay, so once I have like my new model updated, I can go through the app. I can go to the app as well again and upload this very same image that Ali was uploading earlier, and we can try with this new model. Basically, if the demo works, and it's gonna like basically detect that there is Knative in this case, and of course, in this case, it means that the model confidence was high enough for the model to say, yes, this is actually Knative logo. I'm pretty sure this is actually Knative logo. And so in this case, we kind of have a full application in a way that, we have evolved the application and we have also updated the application to kind of serve a new model, like without like dropping any kind of traffic to it. And with this, the demo is done. So I'm gonna switch back to the presentation and kind of talk about like some key takeaways from these re-architecture of these like specific use cases we have kind of solved. And one of the key takeaways is like that the AI part modules of your like system is going to be like a fast moving target basically, and you want to have like an architecture that is enabling that fast paced evolution of the model and the AI model in particular. And so with like event driven architecture, usually like this is like by design is going to be like supported and supportive for your teams that is kind of expert into like the AI area. Also, like another key takeaways, like we saw in the like previous architecture, we kind of saw that think about like when you're designing a service, think about like how the various like operations are kind of done, and if they are like atomic, and what's the data consistency if some of them fail. And so as the Murphy law says, anything that can go wrong will go wrong. And so in the previous case, if the store prediction action is not will goes wrong, we end up with an image in the object store that has no prediction for it, which is not happening in the in the alternative architecture. And of course, at the end of the day, there is like no silver bullet. Like one architecture is not better than the other, like in all sizes and all cases. But there is complexity into like the alternative, and the complexity is kind of distributed into individual components that are like simpler individually, but like overall there is complexity anyway. And I don't think like complexity can go away completely, but there is going to be complexity anyway, and we need to kind of find the balance between like where is the complexity exactly. And these are like the key takeaways, and and with this we end the presentation, and if you have any questions, I'd like to answer them. And Ali, do you want to add something there?
Yeah, so I don't see any questions in the comments, so we can end this. So it will be a short presentation, obviously. Normally the events in this group take like an hour or something, but yeah, we really wanted to do this like in a conference, 25-30 minutes. So this is it. This is it. Thank you very much, Pierangelo, for joining me.
Thank you.
And yeah, I hope I hope to see you again in this group again in the future. I switched to Turkish now a little bit. Okay. Teşekkür ederiz herkese katıldığı için. Sorularınız olursa offline'da ulaşabilirsiniz. Herkese iyi akşamlar diliyorum.